Hey there, my name is Memo, this is my channel, Houseplantygoodness, and essentially it's a place where I like to geek out about my big passion. You might be able to see some of it behind me. I talk about tropical houseplants. Now today's video is going to be quite different, and this is something that came up through a discussion that I was having with one of my followers on Instagram, and this was kind of more of the debate of going into the more geeky scientific terms for some of the processes that most plants, not just houseplants that we have indoors, will go through. So I thought it might be an interesting topic to dive in and really kind of get into the nitty-gritty of some of these scientific terms, what they mean for you in your collection, and essentially how you can maybe take advantage of some of the natural processes that plants are doing instead of fighting against them. Now, that obviously being said, this might not be for everybody, so if you want something a bit more light-hearted and less scientific, I've got loads of other videos on my channel. Please do go and check those out. But for the ones that really want to dive into it and get a bit geeky with me, let's dive into the different topics that I want to discuss today. Okay, so some of the subjects that I want to be talking about today, and I'm going to be looking down because I've got notes for this one, is going to be things like Skototropism, Phototropism, how those two are different, Apical Dominance, which I have mentioned on previous videos before as well. Then we'll look at things like what petioles are in relation to what a stem is, what gartation is, what cam is. So that is, ooh, and I can never get this right. I'll use the full word instead of the abbreviation when we talk about that section. Then we'll talk about Extrafloral Nectaries, what photosynthesis is, respiration in plants, carbon fixing, cloning versus traditional propagation, which is via pollination, and also what we look at in terms of vegetative propagation versus pollination again. So let's dive into it with the first topic. So the first topic I want to talk about is phototropism, and that will kind of lead us quite nicely into Skototropism. So phototropism, again, I'm going to flex my Greek muscles here. Photo means kind of light or phos, and tropism is basically where it moves towards. So it's essentially the habit that plants have by moving their foliage or their entire being sometimes towards the light. And this is something that a lot of people probably have experienced in their homes, especially if you've got a window in front of your plants and you can start seeing your plants leaning. You might be able to see a plant I've got in front of me. So I've got the alocasia black velvet in front of me. Apologies if the leaves are looking less than perfect, but they have been struggling with mealybugs like everything else in my collection. But I'll bring it in a bit closer and hopefully that might be able to focus. You can kind of see, and you can see the back of the leaves as well. The redness in the back of the leaves gives you a bit of an indication. A lot of the times with most houseplants, if they've got red backs to their leaves, it generally tends to mean, not always, but it generally tends to mean that these plants are used to being in the understory of the forest. So they're used to having slightly lower lighting conditions. So what you might be able to see with this plant is it's leaning, and it's leaning because unlike a lot of my other plants that are getting top-down lighting, this plant is in one of my shelves and it's getting lighting coming in from this direction, which is where the window is. So naturally what the plant will do is it will mechanize all the different aspects of its body, whether or not it's the stem, if it's something that can easily be moved. Some of the thinner plants might be able to do this, or usually the petiole. And the petiole, again, this is another topic that I wanted to talk about, is the difference between what the stem is. The stem tends to be the main bit of the plant that is growing up from the soil. It tends to, after a while, get a bit of a more of a woodier texture. And the petiole is the part that connects from the main stem. So think of it, if you're thinking about trees, that's probably a good analogy here. The trees, the stem would be the trunk of the tree. The petiole would be what connects the leaves to the branches in the tree. But in this case, for most houseplants, it connects the leaf to the actual stem, the main growing stem. So this bit here, which a lot of people sometimes we'll call a stem, isn't technically a stem, it's a petiole. But what it will do with phototropism is it will move the petioles and it will bend them in a way so that the light will actually be getting to the leaf as much as possible so that it can photosynthesize as much as possible. I will bring you another example and you will see this in a bit more kind of detail to understand what I'm talking about. So I've got my Philodendron biliter in front of me, and again you can see the phototropism, and for the people that have seen the review of this plant, which was only a couple of weeks back now, a lot of the leaves were pointing upwards, very similar to this leaf here, which is pointing upwards, because at that point in time the only light it was getting was top-down lighting. If you see the leaves now, and I am exceptionally proud of the new big leaf that I'm finally getting on this plant, because if you consider the leaves when I first got it were smaller than this, so this is a good move for this plant. You can see now the light now that it's coming into spring, and you might be able to see because it is washing me out. I've only been able to put my net curtains up for the people that have seen the conservatory tour. Now when it gets into more the spring summer months and there's a lot more light that comes into the conservatory, I need to put things up like net curtains and also shade cloths. The net curtains are in, the shade cloths are not in, unfortunately, and that is probably what is blowing me out. But with the way that the conservatory is, I've chosen the shadiest bit. Let's just go with that basically, because other places it's a bit rough at the moment. And if I'm looking at the thermometer in here at the moment, also why I'm in a t-shirt, even though it's relatively still quite cool in the UK, it's 32 degrees in here at the moment. Summer holiday, anyone? But sorry, massive tangent there. But you can see now that the leaves are pointing towards where the light is coming from, because the light is coming up this way, so they've started to bend down and out towards the light. That gives you a good indication, and this is something that the plants can do. Not all plants, some plants can do. It's not as if a leaf is going to move down towards the light, that's where it will always be. If the light will always be there, that's where it will be. But actually, if you then move that plant and give it, for instance, top-down lighting, these leaves will also then start moving towards that light. So it's a dynamic element to the plant. Now, moving on to Skototropism. Skotavi in Greek means dark or nighttime essentially. And Skototropism is something that some plants, not all plants, will do. And I've got a plant here that I will show you in a minute, that basically they move towards the darkness rather than the light. Remember with phototropism, they're moving towards the light. So you'd kind of sit there and going, why would they move away from the light that would provide them with what they need, which is essentially the light in order to photosynthesize and grow? It's a very interesting survival tactic that a lot of plants have. It's very predominant in Monstera. Unfortunately, most of my Monsteras are a bit too large for me to kind of easily bring out, but I have got a Philodendron Ploumanii here, and you might be able to see what this leaf is doing in terms of the petiole when the rest of the leaves are up towards the light. And don't judge me too much on the yellowing on these leaves. This plant is struggling a bit to transition into pollen. It's getting there. I'm just going to have to deal with slightly unattractive leaves for a couple of weeks, basically. But what you can see here is it's moving away from the light. And let me put this down and I'll explain why. So the reason why a lot of plants will do this, and I know it's a bit of an odd example for me to be giving you the Ploumanii because it's crawler, but if you think about your average Monstera, now, what a lot of these climbing plants will do is they need something to climb up. And if you think about it, if you're in the jungle, if you move towards the light and you've got the canopy and you've got all the leaves above and you move towards the light, it might just be an area where the light is trickling through, but there isn't anything else there. However, if you as a plant would move towards the dark, which would signify that you're moving towards a tree and more specifically a tree trunk, you can then latch onto that tree trunk and slowly start heading towards the light whilst also attaching things like aerial roots onto the actual tree trunk, which will give you the support that's needed and will help you get larger and larger leaves, basically. So that kind of explains why plants have come up with this ingenious notion. As I said, not all plants will do this, where they will move towards the darkness because they're thinking that there is a tree there that they can climb up. In your situation, in your household, if you maybe give them something to climb up on and attach them to it and maybe bump up the light, they can then start thinking that, oh, okay, fine, I've attached to a tree now and I can start moving up. I don't have to move towards the darkness. I can start moving towards those higher light levels by moving up whatever they're growing up, moss pole, plank, whatever it is. So that's something that you could take advantage in order to kind of trick your plants in thinking that, yes, you've attached, you don't have to go towards the darkness now, because obviously darkness means smaller leaves, it means leggier growth as well, because again, think of what it's trying to do. It's trying to get to those tree trunks. It's not getting any light, but it's trying to get to those tree trunks so it can grow up. So it's not going to put a lot of energy into bringing out big leaves or making sure that the leaves are quite close to each other, because its ultimate goal is to hit that trunk and go up. So if you basically play with the system a bit there and give that something to climb up, it should make a bit of a difference. So let's move on to the next topic. Okay, so this is a topic that's near and dear to my heart, and I've talked about this a lot in different videos, and people do this, and they've been doing this for years. They don't necessarily know that there is a reason or kind of a naming behind it, and it is apical dominance, or more specifically, releasing something called the apical dominance. And I'll bring you up an example so you can see. And you can see with this philodendron, the apical dominance, essentially what it means is where the growth is most dominant, and it will generally be on the main growing stem. Now, what does releasing apical dominance mean? It means going in and potentially cutting that growing stem, getting a propagation, propagating it. What it does is, instead of the plant then putting all of its energy to go up, it will then start rooting energy, because obviously you've cut that up motion that it was doing. It will put some more energy into some of the lower nodes and activate secondary growth points. So something like releasing the apical dominance is a very, very smart way of being able to make your plant bigger, bushier, because essentially what it can do, and I have seen on a few plants, I'm trying to think if I've got any that I can bring up at the moment. Nothing's coming to mind, but it happens without fail with most plants, is sometimes you might get one node activating lower down and you haven't got much of a branching. Generally, you will tend to get at least two nodes, so you'll get two branches coming out. This is something that a lot of people will do and a lot of nurseries will do. So I don't know if you've ever noticed with ficuses, that's something that you can kind of see. And I think the name is, I can't remember, one is standard and the other is tree. I'm not entirely sure. I'll double check and I'll put up the comments here. And think about a ficus elastica or a fiddle leaf fig. You can either get them as a column, so growing up just one, or you can get them where there's a column, a bit like a tree trunk, and then there's branches basically. What they tend to do in the nurseries in order to get that to you, and also something you could do in your household, it does take a while, especially with ficuses, is when you snip that tip, it then starts branching out, and then some of these plants can start looking like trees. If that's ultimately what you want to do, that is the way to do it. The tricky thing, and I'm moving away slightly from ficuses now, thinking maybe of a philodendron, you might get multiple nodes activating. So let me bring up again the philodendron that we were looking at. If I was to cut the top tip and release the apical dominance, I might get one or two buds forming and one or two branches, or I could get every single node, and I've seen this happen a few times, usually with slightly smaller plants, every single node activating. Whether or not every single one of those will lead to a branch, or maybe only some of the top ones will, that's a different story. But that's something to bear in mind. So releasing apical dominance is quite a cool thing, because essentially you can get a much bushier plant. And also if you've got propagations from it as well and you grow them, you can put them in the same pot and get an even wider plant if that's what you're going for. But yeah, I think that's what I want to say about apical dominance. Let's move on to the next topic. Okay, so we've talked about petioles previously. But what I want to talk about now is something called guttation. It's a horrendous word. It sounds like it could be naughty, it isn't. But you've probably seen this specifically if you've had an alocasia. It does also happen sometimes, I think, to my monsteras and to some of my philodendrons. I'm trying to think if it ever happens to my anthuriums. Maybe. Let me know in the comments down below. But this is specific to alocasias, colocasias, more so than everything else, because you'll see this. It's when you are looking at your alocasia or colocasia leaf, and at the very tip, and I'm trying to, let me bring up the black velvet alocasia again and we can talk about it whilst looking at it. So you've probably noticed on your alocasia potentially right at the tip, you might get a drop that's about to drop out, and you're sitting there going, what's my plant doing? Is it leaking? What's happening? Why is it dripping, 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 dripping? People that have alocasias, especially slightly larger alocasias, be aware that that drip will happen a lot of the time. So be aware of where you're putting it on. If you're putting it on wood, just be aware that there's constantly going to be drips coming from those leaves. And I've done an entirely different video on guttation, and I'll see if I can find it and link it at the top there. I'm not entirely sure if it's on Instagram or if it's on here. So if it is on here, I'll link it. If not, it might be on my Instagram. Follow me on Instagram as well. The link is essentially in the description below. But back to guttation, what it means is that plant is sucking up a lot of water and essentially it's releasing it from that leaf tip there. And it might be because there's been inconsistency with the water, there's a lot more pressure that's coming in because it might have stayed dry for too long and it's sucking up the water too much and it's kind of trying to release some of it. Because if it doesn't, and this is a topic, bonus topic, I didn't think I was going to talk about this, edema. Now, plant edema can be quite unsightly. I've had an issue with this with some of my plants. Unfortunately, as far as I'm aware, it's more preventative than curative. But you might get, and I'm trying to see if maybe some of these leaves have got it, not so much, but you might see on a leaf, you might get something like a blister or a pimple almost, and it's usually filled with fluid. And essentially what is happening, and again, it's a water issue basically when it's absorbing water too quickly for whatever reason. And essentially what it does is those cells burst and it causes that blister. Unfortunately, there's nothing you can do to fix that. You might want to relieve that blister by popping it open. Just be careful with that. As with normal blisters, you might be introducing pathogens into it. But when you've got it, you've got it. There's not anything you can do to make it disappear. You can do preventative measures in terms of being more regular with your water. I've not found most of the preventative measures to have worked for me. So if you've had experience with edema and you've had good success, drop a comment down below. But yeah, so with guttation, it's the same thing. Essentially, it's just releasing that water. It's completely normal for your plants to do this because I know a lot of people, when I first did a bit of a video on guttation, they were just like, oh my God, that's what it is. We really worried that there was something wrong with the plant. It isn't. It's a normal process that the plant will go through, but it is worth noting that some plants will do it more than others. It's usually to do with kind of water irregularities or water inconsistencies, as far as I can tell from my own research. But alocasias and collocations will do that at the drop of a hat, even if there wasn't too much of a water irregularity. So bear that in mind and just be careful where you put them, basically. Okay, and moving on to CAM, and I've got a tablet here because I can never remember the full name. It is crassulacean acid metabolism. And it's a very scientific word, but essentially what it means is it's for certain plants that are used to growing in arid conditions. So think about your succulents, think about your cactuses. What it does is it allows the plant to photosynthesize throughout the day, but keep its stomata closed. And I'll talk about stomata in just a moment. So it doesn't kind of respire or transpire, so it doesn't release gases during the day. Because if you'd imagine, if you're in a very, very dry and warm condition, releasing that during the day would probably mean that you're releasing more than you probably can afford to lose because of those warm conditions. So what these plants will do is they will do that at night when the temperatures are lower. This is also something really interesting to think of. And I know there's a lot of people, and there's the research that everybody was just like, yay, getting houseplants will help improve the air quality because it's been proven by a paper from NASA. I know there's a lot of people debunking this, but let me also add my 5 cents into that as well. Yes, that could happen. The volume of plants that you would need to have in whatever room you're talking about at that point in order to see a significant improvement in the air is huge. You'd need to be in an actual jungle, basically. So I don't think even this specific room would do it, basically. So that gives you an idea. But just get plants because you like them and because they make you feel better. And yes, there'll probably be some very minute improvements to the air quality, but which also then leads into how CAM can be quite important to some people because they might be putting plants in their bedroom when they're sleeping. And again, I am not a botanist on this, I'm just a hobbyist. But I would imagine at the same level, you would need a huge volume of plants to be transpiring and basically releasing oxygen, whilst pulling in carbon dioxide. And if they're pulling in carbon dioxide at night, for example, there's an issue there that is it safe for you to be sleeping in that environment and all of these things. So, but CAM basically means that those plants are relatively safe to put in your bedroom at that point because they're also releasing oxygen at that point of the night. But again, as I said, pinch of salt, because you'd need huge volume of plants in order to really make a significant difference. But yeah, CAM, or crassulacean acid metabolism, I still need to look at my notes because I still cannot say that off the top. Doesn't really roll off the tongue, does it? Is kind of a bit of a cool process, and it's the way that some plants have adapted to their conditions. So that's kind of cool, actually. And it might also give you an idea of when might be best to water some of these plants as well. So you probably already know this, but maybe don't be watering some of these plants, even the succulents, in the middle of the day. Because if you think about their environment, the time of the day or the time of the 24 hours that they would be getting some of their moisture might be at nighttime when the temperature drops and it creates a bit of humidity. And that humidity is essentially what waters them. Also, with a lot of arid areas, it tends to rain mainly at night. So the plants are adapted to their environment. So see if you can replicate it. So for instance, if you've got succulents and cactuses, try watering them before you go to bed rather than during the day. Obviously, as long as they're getting a decent level of light. Next topic is extrafloral nectaries. And I don't think any of the plants that will... Yeah, I can't really lift. My plants are getting a bit too big. I can't really lift them to show you. I'll see if I can put a picture here. This is something, and people who have experienced this will understand what I'm talking about. On the petiole, sometimes on the stem as well, sometimes even the back of the leaves, you'll get little water droplets, and they're not technically water, they are slightly sugary solutions essentially. And it's a very, very cool thing that the plants do, almost as a bit of a natural pesticide. And I'll tell you how. Because essentially what it does is it releases these kind of sugary water droplets along its stem, along its leaves. And what it will do in nature is that will attract things like ants because of the sugariness of that fluid. And what then happens is the ants are just like, great, this is a great food source. So let's protect this. So when other pests come there, then those ants, in theory, would fight those pests. Now, it gets a bit of a grey area because certain pests that kind of attach, and I'm thinking things like aphids, I think, do this. I think mealybugs potentially might as well, where they kind of attached to the leaves or the petioles or the stem of a certain plant, and they're sucking out the kind of liquids of the plant. I'm trying to think what it is now. It will come to me. If not, I'll put the name at the top there. And a lot of the times what these pests will do, their poop, essentially, or their pee, tends to be quite sugary as well. So then the situation that occurs is that the ants will go on there and they'll protect the pests, because the pests are what are creating this sugary substance. So yeah, something else for you to worry about with pets. Sorry, I don't mean to add more stress when you're worried about pests, but it is something that happens, and you'll notice this. I notice this a lot in my conservatory because obviously ants can come in here during the summer. If I've got a huge ant, not infestation, but a lot of ants on a specific plant, I will check for extrafloral nectaries, but more specifically, I will check for pests, because it might be the pests that are kind of bringing those ants in. And as I said, I'll hopefully would have found a picture and put them up there so you can see what that looks like. But hopefully people that have experienced this might put their minds at ease slightly, hopefully. Now, photosynthesis. And I'm going to touch on this at a very high level because it's a very involved process if you really want to find out a bit more about photosynthesis. And I do encourage all of you, if you're really getting into your plants, to do this. It will give you a better understanding of what the plant does in order to survive. So do use some of your research, dive into it as much as possible. But essentially photosynthesis, on a very basic level, is they transform energy from the light source that they might be getting in the sun and water and nutrients that it might be getting from the soil into more cells so it can grow. So essentially it's food. The sun and the water and the nutrients is the food the plant needs in order for it to grow. The example goes that if a plant can't photosynthesize, if you put a plant in a dark cupboard for a year, it will die a death really quickly because it needs the sun in order to photosynthesize. But that's as far as I'm going to go into this. It's a very involved topic, as I said. Do check it out online, do your own research. Google will be your friend. And yeah, just dive into it. There's websites out there that are very, very simplistic and you can understand them. And there's also more scientific websites out there that you can really dive into the topic and a lot more, basically. Moving on to respiration. And essentially, this is where gases are exchanged from the plant. Now, in a leaf, and this is where the stomata comes in, stomata or stoma in Greek means mouth. And if you look at these cells of the leaves usually, under a microscope, they do look like little mouths. They look like two little lips that kind of open and close. Do search on Google and you'll see what I mean specifically. But what this means is that essentially the gaseous exchange. So it will be pulling in carbon dioxide that it needs in order to photosynthesize, and it will be releasing oxygen because that is essentially the byproduct of the photosynthesis. So it's kind of excreting that because it doesn't need it. It's great because obviously plants create oxygen for us. That's why forests and the tropical forests and everything like that, they call them the lungs of the earth, because essentially that's what's breathing the oxygen back in. They are taking away that carbon dioxide that we're producing and a lot of like industry is producing, and they are using that for their own growth and then releasing oxygen, which is what we need, which is kind of awesome and kind of cool. Sorry, I'll get off my hippy-dippy train now. But what it also means is, and this is something that people maybe don't realize, and this is another reason why a lot of people talk about light, airy, aroid soil mix. And I want to focus on the airy part of it as well, because what you might not realize is that roots also create a bit of a gas exchange as well. So that explains why you want the soil to be airy. And obviously different plants need different levels of essentially air or carbon dioxide or whatever the gas exchange is being done. I'm not entirely sure what the specific gas exchange. I would imagine it's the same as the leaves that is happening in the soil, in the roots. But if you've got a very dense and very compact soil, there's no air that's getting to those roots, so they can't respire essentially. So that is why it's so important, and different plants have different needs. A lot of the tropical plants, because of what they grow in nature, where they are in their natural habitats, which is very, very kind of leaf debris and all these things on the forest floor, those roots need a lot of oxygen in order to be happy, maybe more so than a plant that might be a carnivorous plant that might be in a bog where there's very little oxygen usually in the soil because it's a bog. But that is why it's so important as well to make sure that most of your plants, by the way, even things that are growing in a bog, they still need a certain level of aeration within their roots to keep them happy. Because again, that respiration also happens in the roots of the plants. Now, the next topic I want to talk about is something you've all probably done, you just didn't realize there's an actual term for it. So for most people, propagations. So we've all at least tried once or twice, hopefully, to propagate. And if you haven't, I do encourage you. It's great fun because you do feel a bit amazing after it works, because you're just like, I created something. But with traditional propagation, where you take a cutting and then you root out that cutting and create a new plant from that, it is called cloning. It's cloning. It's a cloning form of propagation, and it's been going on for years, because essentially what you are doing is you are creating a clone of your original plant. A lot of people might call that your mother plant. So the plant that's created from it is a clone of that plant. And this is quite interesting because you see this a lot of the times with certain variegated plants that maybe come out. A lot of the times the variegation isn't always genetic. So the only way that you, as in genetic from seed, which is the other way that you can propagate, and I'll come back to that in a minute, but with something that's got like chimeric variegation, which is specific to that plant, because essentially it's a mutation of the plant. In nature, most plants would not want to be variegated because it limits how much they can photosynthesize, so they're at a disadvantage. So evolutionary wise, they would prefer to be all green. So a lot of the times what you would get with things, and I'm using variegated plants as an example, is they are clones of a parent plant, because that's the only way that you can guarantee that that variegation will continue. This isn't always for variegation only. There's sometimes when a plant has got a certain trait that you really, really want to make sure kind of consists. So for instance, I'll think about of an anthurium now. There is, I think the clarinervium is one of them. So I think it's something called the king of clarinerviums or something like that, which has got much more intense veination on it. That is a clone propagate from a plant or two that might have had this, and every other plant from that has been a clone of that plant rather than seeds necessarily of that plant. I'm not entirely sure specifically about that plant, but that could be an example of it. I'm trying to think of other things as well. So for instance, if you've got a sport variegated plant, so you've got a green plant, usually from a box store, this has been discussed a lot recently, and you might get a bit of variegation on it, and it kind of ends up becoming a more stable variegation on that plant. It's not the traditional albo or the oreo, which is the yellow variegation, or maybe that monstera. The only way that you can guarantee that you'll get more plants with that same sport variegation, which happened at random, is to take cutting, propagate it so it's a clone of that original plant. And then to round things off in terms of the traditional way of propagating, which isn't through clones, it would be through pollination. So it would be by pollinating a stamen on an anthurium, and the same thing would go with most aroids basically. It's most plants actually. It's when pollination happens and seeds are produced, and then you can create progeny from that. Now, really interesting, and this isn't just, I'll touch on other plants as well, not just houseplants now. It's really interesting what happens, and I think I remember seeing a YouTube video about this a while back, but there are certain plants that you need to get clonal propagates in order to guarantee that you'll get the same thing. So I'll give you an example. And again, this is a while ago that I watched this. Hopefully this is accurate and it wasn't like a random video. But with potato plants. So with a potato plant, if you are to get seeds from the flowers of the potato plant and you're hoping to get the same type of potatoes, you won't. It creates a new type of potato that is different from the parent plant. So when you plant that out, you might not get the same potatoes that you were thinking of before. I think tomatoes are another one that's like that. Pecan nuts are the same. And yeah, which I think is really interesting because it's nature in itself making sure that it's producing something that improves time and time with a new progeny, essentially. So in humans, in terms of genetics, it might be, and this would happen over hundreds of years probably, if there is somebody who's got a natural immunity maybe towards cancer, it will prefer to go down that route and create more humans that have got an immunity towards cancer, because it will mean that the species will survive, or it will improve and be more tolerant to things as well. And that's why sometimes, and it's happened a lot more with food crops because they've been fiddled with genetically for a while now. But it just means that nature itself will select for the best type of progeny or best type of new plant for that environment a lot of the time. So you might get certain plants, and this is why it's quite interesting sometimes bringing it back into houseplants, where you've got a plant that might be struggling. If you then get seeds from that plant and plant those seeds in your environment, those seeds are probably going to be slightly more likely to be robust in your environment, because the natural stresses that the parent plant might have caused the new seeds to be slightly more tolerant to some extreme situations. Maybe if the temperature drops too much, it might not happen quite so quickly. It might be a few generations down the line, but it does happen relatively quickly in plants because they need to survive, basically. But yeah, I think I've probably bored you with a whole bunch of geekiness. This is the kind of stuff that I read for fun, because I was that weird kid who was really fascinated with plants since a very young age, and I don't think that's ever really gone away. But yeah, if you want me to do individual videos that might be more in depth in certain topics that I've talked about today, do let me know. Each one of these could be their own video. I just didn't want to bore everybody to death, essentially. But if there is a a desire for a more in-depth video on any one of these topics, do let me know in the comments down below. But yeah, hopefully you've enjoyed. Hopefully I shall see you here soon and I haven't scared you away with all the like scientific talk. And yeah, I really, really do hope that you have a great rest of your day. Thanks. Bye.